So I'm just going to highlight a few things. So for writing the inequalities, this was regular shading, which means that the true region is shaded. And so technically, if you want to think of it this way, true region is below the line. That's why you had to go less than. And it's dashed, so no equal. Okay. In terms of your slope, just make sure you are able to replicate the slope you come up with. Some of you came up with like, I don't know, 4/1. If you're able to go 4/1 and you stay on the line, then you're good. But if you can't, try again. Check. Okay. So this is actually 3/1 and it's positive because the line is going up. So 3x minus 2, this is based on whatever your y-intercept is, whatever it goes through the y-axis, that's what this is supposed to be. Okay. Next, it's reverse shading. So this is true. Remember, always focus on where the true region is. So true region is above the line in this case, so it's supposed to be greater than, and it's equal to because it's solid. And my slope is 4, 3. Even if you compare to this point here, it's 4 units and then 3, 4, 3, and it's negative because you're dropping from left to right. So, and plus 5. I had some interesting answers there, but it's whatever this is, whatever it crosses the y-axis, okay? Next. This one was done fairly well overall. I'm going to highlight it again. You should have flipped the first one here, okay? Because when you rewrite it, you end up having to divide by -3. Remember, this is non-contextual, right? So we're doing all 4 quadrants here. And so I give you a full mark for that. And that, I don't know if you noticed, but I would sometimes circle your shading, like where you told me you're going to shade, and then I kind of verify to make sure. So if you're wondering, like, why is he circling this? Is because that's what I go off of. I need consistency, right? So even if you get this wrong, your rewriting part, I have Desmos going the whole time I mark this. So I was like, if you get your inequalities wrong, I enter what you got, and I quickly graph it, and I check to make sure your corner points match, everything matches based on your graph, okay? So it's work, but it's necessary. So you know what? I have to say, shame on me. I don't have this, and I know I took some marks off for not having X and Y there. Okay, so label your axes always in grade 12 applied, same thing. Most of the time that's contextual, right? It means something other than just X and Y, but make sure you label it. Overall done very well. You tell me where your solution region is. So if you have like a gazillion check marks, it's because I check for all those things, right? That's what I look for. And so well done there. And you end up with 3 corner points. It's only where the lines meet surrounding the solution region, not x-intercepts or y-intercepts. So it's these 3 here. I'm going to probably post this one later. And to check if it's a solution, you need to input these points into all inequalities and check if all of them are true, and they are. Some of you actually did the math right, but you said it's false. And you stopped, which is what I told you to do. If you do find a false, then you stop, right? But let's put it this way, folks. Watch this. Where's -5? -5, 1 is right there. So you know it's in your solution region, correct? So this one you could actually verify to make sure that you were on the right track. And then you have to end up telling me it is a solution, in fact. Okay. Sounds good? Just and then grab a white copy if you don't have one. See ya. All right. Next, backside. When it's 1.5, you should be suspicious already. What's that half all about, right? That's this, your implicit constraint. So number of cows, number of chickens, And here are your three inequalities, right? This one talks about the space, okay, space restriction. So 40 for a cow, 5 square feet for a chicken, that has to be less than or equal to 1200 because you only have that much space available. The next one was on money, right? This one had to deal with money. So 1000 for a cow, $50 for a chicken. And so that has to be less than or equal to 20,000. And this one is just based on the cows, right? So greater than or equal to 5 is just X. So there are your three inequalities. Way to go. Most of you got that. And when you graph that, so I'll just let you write down those inequalities. And if you want to correct this, if you want to do this again yourself, you can do that, right? You can grab a piece of loose leaf and just do it and staple it to this, and then you have it. But again, I look for the intercepts. This one didn't need any intercepts, but I'm focusing on where am I shading? Okay, shade above here, shade above. So above to the left. So when I graph, I'm expecting above those diagonals and to the left of that vertical, and then I'm left with my solution region. Very well done. I would say great majority got all of it right, if not most of this. So way to go. You labeled your boundary lines. You had a good scale, all of that stuff. Way to go. I didn't find anything. And then the corner points, you could read two of them. Those are your x-intercepts. And then for these two, you probably would want to use your calculator. Even if it looks suspiciously close, use your calculator for anything that is up here in your grid. The x-intercepts you already know, right? You calculated them. But if it's not, make sure. And then you round your corner points because in this case, we can't have partial chickens or cows. Okay. Next. I basically just added on an AC that I never gave you on this one. And see, because this one had to deal with optimization. This one dealt with that part. So children's haircuts, adults' haircuts. I have to say something here. Some of you flipped this. Some of you went adults, children. Nothing wrong with that, but your graph, everything is going to be opposite. So your corner points are going to be flipped. Like the numbers are not going to be the way I have them. They're going to be the other way. That's fine. There's nothing wrong with it. You just be consistent and you're going to be fine. Okay? You're going to lose 0 marks for that, but your graph will look different as well. Your graph will look as if this whole thing turned clockwise. Your graph's going to look like that. So nothing wrong with that. And so this one was the tricky one. We want at least five adult appointments for every child appointment. So this is a child appointment. We want 5 times that for your adults. Okay, so this is the counterintuitive part, and you definitely want more of the adult haircuts. Okay, so that was 1 mark, and then at least 90 appointments. So you take your appointments or cuts, and that has to be greater than or equal to 90. And then you had the time available, and that's where the half, I would take off a full mark if you got it wrong, because your graph is significantly different if you miss it. But it's worth half a mark if you do it. Like I give you that half a mark for doing it, okay? So you get 9,600, so you turn your hours into minutes. I think one person turned everything into hours, which is fine. Like if you want to turn those 20 minutes and 45 minutes to hours and stick with 160, then you're fine, as long as your units are all the same in that inequality. And when you graph this, I think the tricky part was the first one, this one. So you remember, you start at 0, 0. This one goes through the origin. To find another point, you let x be anything you want. If you choose 10, then you plug 10 in there. It's 5 times 1050. So basically, this is my second point. So 1050 is right here. 1050. No, sorry, 1050 is right there. And then I just go along. If you had picked 100, you'd be way up here, right? That'd be technically 500. Why is this off? It's a little off, but it still works if you. I think because of my scale is not quite as accurate as the calculator, but as long as this looks like what the screen shows, you're gonna be fine. And so your solution region ends up being in here. So the other ones I just figure out my intercepts just like before. The x and y 90, I just do it right here and I rewrite it right there. So be creative with the space that you have. And make sure that when you sketch this on your calculator, that it matches what you have on paper. Some of you made a mistake in your rewriting part. So this graph will probably be correct because you're using the intercepts you found. But when you plug the rewritten forms into your calculator and you hit graph, make sure it looks like what you have here. What I would suggest is change your window parameters to what you have chosen here to kind of match it, right? So my x max would probably be 500. My y max here would probably be in the 300s, something like that to see what you want to see. Next, based on this solution region, there were 1, 2, 3, 4 corner points. So 0, 90, and this one, these two here, I could just get it off my graph. And then these two here, I had to use my calculator to find, right? 1575 and 39, 196. Okay. So there you have it. Next, this one, folks, this is this I might have to focus in a little bit more for this one. The objective function is not an inequality, so it shouldn't have any greater than or equal to. It should always have some kind of letter. You can choose whatever you want. You can do hours or T for time, F for function, it doesn't matter. But a capital letter, and then sometimes there are coefficients, sometimes there aren't any, like it's just one. But because we're talking about hours spent styling hair, this would be able to give you for sure the time. It would be in minutes. You'd have to convert that to hours, right, afterwards. But this is the objective function that we would use in this case. And then once you've done that, when I ask you what's the greatest time spent styling hair, you take all your corner points, you plug it into your, some of you got this wrong, but I saw that you were plugging your corner points in, and the max is 9600. So really 39 children's haircuts and 196 adult haircuts will maximize the time. Okay. Phew. Lots of work on this one, I know. Go back to the last page. Here's the key for this one. Okay, where's my solution? It's in this region right here. Which means if I want to focus on line A, this one right here, then I know that the true region is where? It is above. So right, true region is above for this one. So I know that it's going to be y is greater than, and it's dashed, right? So I'm not going to do the equal. 6 over 7, 60 over 7, doesn't matter. Don't forget about the x. Okay. And then this is plus 10. Why? Because it goes through here, and it's not 1, it's 10, because look at this scale, right? This is 50, so that means that every box is worth 10. So be mindful of that. So 10 there. For line B, this one, this is the solution region, right? Like I can tell that this wasn't shaded, or sorry, this is where the true region is, so this is false. True region is to the right, I can tell, because if this is my line and this is the solution, right, then this is the true region, which is to the right. So you have to go greater than and just greater than because it's dashed, negative 120. So you see where does it cross the x-axis? Right here. This is negative 120 right there. And for the last one, for line C, it's true is above. So true is above, it would be greater than and equal to, or equal to, I should say. So I want both because it's solid, negative 20. Why? Because it crosses negative 20 right there. And so that's how you got your inequalities there. The last part was to enter all of these into your calculator, right? Use your calculator and figure out your POIs. There are only two. There are only two in this case. It's no context, so only two POIs there. Okay. So we don't consider x and y intercepts in this case. Only when it's a word problem. That's it. That's all.